The mass of a neutron is 1. Protons and neutrons are the same, so the mass is 1, and then the charge is 0 because it's neutral. Yeah.
Shouldn't the 50 be on the bottom of that set?
Yeah, it should. You're exactly right. Thank you. I don't know why we're at 70. Senior moment, I guess. We're on a late bus train. We're on a late bus. Okay. I'll mark you tardy in a second. Not absent. All right. Anybody else? Whoops. Anybody else question on the opening other than the stupid mistake I made? You okay over there?
My eyes.
Huh? Yes, we're going to go over homework. Anything else on the opening before I do homework? I want to see homework today. So if you'll pull both sheets out and let them side by side on your desk so I can quickly run up and down the aisles. No, I'm not literally going to run, but move up and down the aisles quickly. That would be great. Yeah. Yeah.
Excuse me. I don't
Okay, do you want where we supposed to?
Well, I was hoping you'd realize one number is bigger and one number is smaller. So the bigger number is the what? And the smaller number is the what? Yeah. I was hoping you would be able to figure that out because y'all are all very smart people.
figure what out.
The bigger number is the what?
Math.
And the little number is the what?
Number.
Yeah. That's sort of what I was thinking. All right, good. You just left 14 blank. All right, fix it now that I just told you what it is. Big number's mass, little number's number. So fix it now that I just told you all that. So if you're one of the people who's like, I don't know what that is, and you only have 14 blank, fix it. Very nice, Raylina. Did you Google it or did you figure it out on your own? Very good. Okay? Good. Good job. Good. 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 What's going on in here?
Smell healthy.
You people in your ABA classes. If she shows up with it, I'll give you a late break. Yeah, well, hold on, let me look, because I don't think I've restocked from last year. Let me see, what's the other page? Okay. The other one? Did somebody give you one?
Yes.
Okay. I need to look, because if I don't, I need to restock. All right, now that Trevor is here. I'm only missing Zion. All right, got it. All right, so if we look at the homework, let's do the one with the chart first. Rather than me calling out all these answers. I need to shrink that just a hair. There we go. There, check yourself.
So on number 2,
Yeah,
like where it says C-12, like I got all of them right,
yeah.
but like why wouldn't it be like carbon spelled out -12? Like,
Sometimes some texts will use a hyphenated C-12. You will not see me do that. I will always spell it out and write carbon-12, but some will do that.
okay.
I won't. Other than it looking weird the way they wrote it that way, are we getting the answers right? Huh? I told you yesterday we had a quiz. I told you the day before, actually. Yes, Matra. Yeah, as long as you just wrote the symbol, it's fine. I didn't care if you put nuclear symbol notation. I don't know if I said this yesterday, but anytime you have a single letter, it's always capital. Anytime it's a 2-letter symbol, the first letter is capital, the second letter is lowercase. I will emphasize that again probably Tuesday because we'll start naming. But some of you will want to write everything in capitals or everything in lowercase, and I will mark that wrong. All right, there's a distinct way to write symbols and letters, and they have to be done the correct way. All right, anybody have a question on any of that? For my overachievers who did the whole page, there are the rest of the answers. Because yes, there are some people in the room who did the entire page.
We're not overachievers. I'm just dumb.
Okay, I said 1 through 10, but for those of us who did the entire page, I don't know what to tell you. All right, so the second page, and I'm going to do the same thing. I'm just going to stick the answers up here so I don't have to call them out and people say, what was that answer again? I'm not assigning the rest of the questions. At least I think I have the answers written down. Yeah. So if you write down all the answers, you're just writing down answers to questions we're not going to do. And I can make that bigger because I know these are a little small. There, makes it a little bigger.
Wait, I'm getting confused.
Questions, other than I need to show you the answer to number 14. All right, there's 14.
I'm trying to get my eye like water.
Anybody have eye drops in the room? Why don't you go put water in it from the water fountain? I mean, since nobody has any eye drops in the room.
Wait, I thought you was asking.
Huh? No. Just told you to put water in it. Why would I charge you a hall pass?
I don't know, some teachers are like that.
Anybody have a question? Anything you want me to work?
Wait, what's the quiz on?
Oh.
Converting moles.
What? I'm not the only one who don't know what you're talking about, so
What do you think the quiz is on?
I'm guessing this, but
Yes.
That's
just
science
making
all
sure.
water.
That's what my son asked me last night. Mom, where's the bleach? I told him in the oven. Where do you think the bleach would be in the house?
In the place where you want.
Exactly, in the laundry area. He asked me where the bleach was.
So,
We have the laundry room.
We do too.
So we keep the bleach in the laundry room.
I keep my bleach under the sink. I keep out of the sink.
We have a laundry room with a shelf with the Tide, the Downy, the bleach. It's all
We have,
together.
like, countertops on one side and shelves on the other.
Yeah.
But we are outside. We have counters outside.
I ain't got that.
I keep it in the laundry room. But I told him it was in the oven.
He just caught
That water in my
a freaking mosquito.
Like,
Then it jumped out on his head and flew away.
Kill it. Don't let it loose.
It was on his phone sitting down. Directly by his head.
All right. Now, other than what is the quiz on, do we have any questions? But how to work anything that was on homework?
What is the quiz on?
Mold.
Oh, that's
So when are we doing that?
In a little while.
In a little while. What's a little while? In a little while, is it today or in a little while?
A little while is in today.
So
Can we
the
just
number
go
of
with-
atomic mass is the number of protons and neutrons, and the atomic number is just the number of protons.
Correct.
Okay.
Correct. Anything else? She's got an eye problem. You got an ear problem. We're struggling today.
Allergies. It's allergy season, Miss Wall.
Okay. Periodic table, yes, ma'am. Yes.
Okay, so
it's always allergies.
I had it in my order, but I had the right answers. Is that?
I don't know. Let me see what you're talking about before I answer yes.
It really wanted to fight today.
No, it's today.
So, Are the numbers on the right P, E, and N?
Yeah.
Then it's fine. I don't care if you put it in a different order. As long as the proton number matches up, the electron and the neutron number matches up with the right letter, it's fine. Yes, that's fine.
Effectively communicated.
Anybody else? All right, you need a periodic table of some variety.
Wait, you.
I recommend a calculator. Y'all aren't too good with that subtraction and adding stuff. What? Which one? So, are the protons and electrons the same? So you're gonna subtract them, and that gives you what?
Oh,
2. That's how you get the +2. Okay, which one do you have more of, protons or electrons? So that's how it's a plus and not a minus. Okay? The protons tells you the intensity, which is what, 30. So you look on your periodic table. And who's 30? Who's number 30? That's how we knew it was 8. And to find the mass, what of these particles do you add together to get a mass? Nope. Well, technically you could do that if it was a regular atom, but you can't with this one because it's mine. You gotta do protons and neutrons. It's inside it. Mode. Counter. Clear. Now you're independent. Okay.
Oh, we can use that.
Yeah, I told you to get out of periodic table. You don't need your, chart, you just need periodic table.
Okay, so periodic table, if there's a quiz that's like, if it could be between two
That's senior year.
You know how that is, how like some of the numbers are like close to each other, cause like.
Remember, atomic number identifies the element, not mass.
So you never like are
It's
supposed
not
to
gonna
round
be
up.
between one and you're not gonna round up. The atomic number tells you the element, not the mass. Okay?
He never paid for it.
He just came out with a drill.
All right. Everybody have their periodic table, and only the periodic table. Put your answers on the quiz, please. Should go here, Ringo, yapping over here. You need a periodic table. Go up there, there's a white one right in front of those trays. It's a paper copy. And then hopefully when mom gets here, you get your stuff and you can show me your homework. That's three. When you're done, just flip it over.
Ms. Wall,
Yes.
can you send Sarah Bermejo to the office please, for a
Yes.
moment?
I will.
Thank you.
Welcome. Take the whole pass, Lyra. Very good.
we have to, like, when we're writing the two rotations, do we have like once we write them, do we need to identify which one's which?
Nope.
Okay,
You know,
sorry.
I'm assuming if you can write both, you know which one's which. Which one we on? Number 6, you have to write hyphen notation, and number 7 has to be nuclear symbol. Here, once you finish the quiz, show me your homework since your notebook literally just came in the door, so if it's in that notebook, it means you did it last night. I want you to mark it late. Yeah,
When we write it out, do we write the whole word or just the? Or just this? No, because on one of them,
bring it here. That way I know what you're talking about and I can answer more accurately. Mm-hmm. On your desk, like usual. And you're still working. Okay. Yeah, it's fine, you can do either one. Maybe you are still working now. Okay, I'm done with your hands, all right. All right, we're done now? Anybody still not? Any second, okay. You done, Zara? What's your homework? I'm thinking about it. Oh, Jim. You done? All right, transfer over to the front. I'll try to have it today before I leave, but no guarantees. All right, those of you who did test corrections yesterday, at this point, that's what I was working on while you were taking the quiz. I have graded everybody's test corrections that did test corrections yesterday. Some of you did not get the maximum number of points you could have. So if you think you got less or you want to check, your test corrections to see if you've got the maximum number of points, by all means, during your lunch or after school next Wednesday or Thursday, check, see what you got credit for or didn't get credit for so that you can maximize your points. Because even if I've not given you credit, you can still correct it and get credit. Some of you I left notes on, like see me or it needs more or fix this, because your explanation was just wrong, okay? The point in test corrections is to correct what you did wrong so you understand why you got it wrong the first time, okay? So even if you didn't get the points yesterday, you can still correct it and get points, okay? So, but they're all back in the stack. Most of you, of course, did not come during lunchtime. Second period is the one that largely came during lunch, but there were a couple of you. Let's talk average mass and mole conversions with our remaining 45 minutes. You're going to need last night's homework sheet at the back side. So if you can find that. Sorry, I have it somewhere. Let's go. Let's go. Here. Go me. Okay, so yesterday we defined an isotope, right? We said an isotope it's an element that has the same number of what? It's an isotope. Anybody? At this point, I'll take any explanation. I heard Elijah say something. Okay, so an isotope has the same protons, I heard. And I heard different neutrons from two different people. For those of you who like titles, put average atomic mass. Now, there's another way to say that. What's the other word we learned that's the same as protons?
Atomic number.
Yep. So you can have the same atomic number. What will cause our neutrons to be different? Atomic mass. So you can have different atomic masses and the same atomic number. Now, yesterday, the example that we used was carbon 12 and carbon 14. Now, today, I'm going to use oxygen. Oxygen has oxygen 16, oxygen 17, and oxygen 18. Now, if those are the three isotopes of oxygen, which one goes on the periodic table? We can't put all three of them on there. We only have how many spots for atomic mass? in the box. There's only one spot. So, what did I tell you we were going to do yesterday? We're going to average. We're also going to average based on, percent natural abundance on Earth. The greater the percent abundance on Earth, the greater percent goes into the average. So if most of the oxygen on the Earth has a mass of 16, it gets a bigger weight. If most of the oxygen on Earth is oxygen 17, it gets a bigger weight. So I told you yesterday, it's like averaging your grades. What has the greatest weight in averaging your grades in my class? Tests. Okay? I didn't realize how kind I was till I looked at my daughter's grading policies at West. Most of their classes, what is 60 or 70% on tests. I'm only 50. I'm really kind of kind. All right? So, there's a formula for how to do this. So once you're caught up, we'll talk about how to do the formula. I see a couple of people still writing. All right, we caught up? Rob, you need more time? Okay. I can't tell with those of you with multiple colors if y'all are just making it look nice or still catching up. All right. I don't think we have to have that because I've already told you all that, but if you want it, you can have it. Here's the formula. All right. Now, you'll notice that you're writing down my formula, that at the end, it says plus, and it has a bunch of dots. Have y'all seen math formulas like that before? I would think at this level you had, but I never actually know if you have or not. So in my formula, I have 3 sets of parentheses that say mass times percent, plus mass times percent, plus mass times percent. So they all say the same thing, right? And then it says plus ... What does that mean? It means ... Means what, Elijah? It continues for as many isotopes as you have. But if I only have 2 isotopes, how many sets of parentheses will I have? 2, okay? These parentheses are for each isotope. So if you only have 2 isotopes, you only need 2 parentheses. If you have 5 isotopes, you need 5 sets of parentheses. Okay? So the formula expands or shrinks depending on the number of isotopes you have. Does that make sense? Yes or no? Yes. Okay.
You don't need to be divided by 100.
It's always going to be divided by 100. Okay? There's a way I could alter that so you wouldn't have to divide by 100, but I'm not going to teach all that. If you know how in math class, you certainly can do and alter the formula. Some of you will figure it out, and it's okay. All right. So here's a typical question. All right? This is chlorine, 35, and this is chlorine, 37, so that we have a name. Okay? And we're going to find their average mass. And I'll give you a minute to write it down. You don't have to draw it in a nice, neat chart form. It's just 2 isotopes. as you can operate the formula, the challenge for most people with this problem is what? What do you think the hard part for most people is in this problem? Putting it in the what? It's the calculator. It's not the work. Okay? So, now the hard part. Use your calculator. I will tell you the order of operations is important. Those parentheses are important in this particular calculation. I will also tell you I strongly recommend you hit equals before you hit divide 100. Now, I don't get bent out of shape about significant digits here. Since the masses have that, I would really like for you to use what that has. Now, this has a unit that I'm going to teach you. The unit is AMU or U. It stands for atomic mass unit. And for some reason, scientists decided AMU was too long and they abbreviated it to U. So you can either use AMU, which stands for atomic mass unit, or its abbreviation, U. You can use either one. Okay, so how do we do on the calculator? If you didn't get it, you need to try it again. You got what?
I did it differently than putting it together.
Oh my God.
Okay, I didn't do it the way I put it on the board.
I've gotten different answers each time, so I really don't know how to.
Let me see it.
Oh, did I multiply by 100 on the last part?
Yep,
Okay.
divide by 100, divide by 100 again. Anybody else? So I can assume that everybody can do that. All right, on your homework paper, do number 4. Is that one that has 4 isotopes? If I remember it correctly? Does 4 have 4 isotopes?
Yes.
That's the one I want to do. Yes, my dear.
So, the average that you found, is that what would be on the,
Yes, that would be what's on your
so
isotope,
that's the
correct.
last one.
Yes.
What is
If we're chlorine, that one should be pretty close.
So for these, do like 34.9 times 75.77, like go across each other.
What do you mean?
Like,
Yeah, I can get 34.96 times
oh,
75.7.
now, I was looking at.
Oh, okay. Yeah, I want you to die over here.
So which one?
4. Yeah, I want to do one that has 4 isotopes. So you got more to put in the calculator. Even as typhoid Mary, put it around your neck. Ready? Three. Is it right? Y'all do anything? Y'all look like you're just staring off across the room. Y'all already done number 4?
We're supposed to do it right now.
Yes! No, next week! Yes, now! I want to make sure y'all can do it.
No, a lot to type in.
I can go home and get this much cooperation. Only he'd tell me I'll do it in 5 minutes. And then still not do it.
Right, go.
So the business is the natural
Yeah.
is we have to we can just put the number that's on the position, sometimes they ask you. Like, okay, we can leave, we put it in the paper, leave as.
Yes, yes. Yeah, the thing that I was saying that you could do is if you don't want to divide by 100, you could change the percent into decimal form and not have to divide by 100. You could go ahead and do that step before dividing by 100 if you want to change the percent in decimals. So you can move that to 0.18, 0.11, 0.62, 0.07. You could do that if you wanted to avoid dividing by 100. You understand what I'm saying? Yes, you could choose to do that ahead of time if you wanted to skip the divide by 100. You could change all the percentages to decimals. Like in math class. That is an option if you prefer to go that route. Yes, it's wrong. I don't know the answer. I guess I could walk up here and look at my key. Because I don't know it off the top of my head. You know I've used the same stuff for years, but believe it or not, I'm not a human calculator or have it all memorized. What'd you get?
Okay, what?
103.41 is what I've written down.
I got 72.2.
Okay, when you get something like that, this is what I need you to do. I want you to look at these numbers right here. It should be in the range of those numbers when you add.
4 to 8.
Okay, so use your math skills and look at those numbers and say, is my number in that range? If it's not, you know you at least have a math error. Because I know you probably wrote that down right.
Where is the answer?
So I told you, most people struggle with a calculator. It's not writing the formula down.
You got it.
What? After what? I probably just chopped it off. I told you, I don't round. You should see some of that stuff I got on last week's quiz.
103.41.
You can, I don't have a
Is that what
problem.
y'all got? Yes.
I'm just telling you, on last week's quiz on significant digits, you'll be appalled at some of the stuff I took. That people had the right significant digits that they rounded. I don't even know what they did.
So,
You can, it's fine. So if you had 103.41, the number after was like a 7. So if you rounded to 0.42 or you left it at 103.417, I'm fine with that.
you
Okay?
don't care how we round it off.
I do. I've just lost the war. I've admitted defeat.
So we don't have to do significant.
On this one, as long as you're in the ballpark, I'm okay.
Oh, I put 76.
All right. Are we okay on how to find average mass? All right. Let's start moles. Yep.
Okay, you got
The
it.
remainder of class will be on how to calculate the moles of something. And
Do we need this paper anymore?
for homework, possibly. I haven't decided what I'm deciding for homework yet.
Go back.
It's the whole weekend. We can't have homework. Right. I remember that. All right. For my title happy people. All right. We're going to talk about mole conversions. Now, the mole is probably the most important topic that you will learn for quite some time this semester because it's going to carry over in all of our math conversions from now through December. Now, first of all, what is a mole? All right. It's the amount of substance. Of course, I should abbreviate this AOS.
That's what it was.
Yes.
Oh.
Yeah. All right. It's the amount of substance in exactly 12 grams of carbon 12. Now, that's the way a mole is defined. Now, we use this as the basis for the periodic table. And just to illustrate that, if I told you that hydrogen has a mass that is 1/12 that of carbon 12, we should be able to find its mass. Okay?
Wait, what does it mean by basics for periodic table?
It means all the masses on the periodic table are based on what I just said. Okay, so follow me on this example, and I think you'll be okay, Allie. Okay, so hydrogen is the first element on the periodic table, so I picked an easy one. All right, so hydrogen has a mass that is 1/12 that of carbon 12. All right, so if carbon's mass is 12, and we're going to take 1/12 of that, what's 1/12 of 12? I heard it over here. It's 1. Now, if we look up hydrogen on the periodic table, what do you suppose its mass is?
1.
It's 1. If we look it up, hydrogen has a mass of 1. Okay? Now, we could do this for every element. We could figure out what percentage it is of carbon to find its mass. No, we are never going to do that. Okay? However, all of the elements have a ratio of a mass based on carbon 12. Okay? That's why the mole is defined based on carbon 12. Now, that's not where we're going with it. We're going to talk about it because the mole is used to convert everything this semester. So, to help you understand how the mole works, I'm going to relate it to eggs. Okay? It's sort of a stupid example, but I think it helps to understand how the mole works. Okay? So,
For me to write this?
it's your
Would it be
notes.
nice to write it?
Probably would help.
Okay.
Okay? So let's say we have 1 dozen small eggs. How many do we have? If we had 1 dozen medium eggs, how many do we have? And if we have 1 dozen large eggs, how many do we have? All right, y'all learned this way back, probably kindergarten number 4. Everybody has it in their head. A dozen eggs is 12. Now we're going to expand on that knowledge and change it from a dozen to another term, okay? So today, we're going to learn about moles. So 1 mole of carbon is equal to 6.022 times 10 to the 23rd atoms.
What?
So instead of saying 12, we have a bigger number. We don't have 12. We have 6.022 times 10 to the 23rd. So dozen is now moles. 12 is now 6.022 times 10 to the 23rd. It's just a different number. Has a name too, I'm going to give you a minute. If I said 1 mole of phosphorus, how many atoms would we have in a mole of phosphorus? 6.022 times 10 to the 23rd. If I said we had 1 mole of arsenic, we have how many atoms? That is sort of paltry out there that all I get is Franco's voice and it's so quiet. All right? It doesn't matter what element I have. I changed from carbon to phosphorus to arsenic. Did I change the number of atoms? No, because it's still a mole. Okay? It's like saying a dozen. A dozen had how many? 12. A mole has how many? It doesn't change. Okay? A mole has that many atoms. Just like a dozen had 12, a mole has this number. Now, this has a name, so if you don't want to say that number, you can call it Avogadro's. Avogadro's number. It's named after an Italian scientist by the name of Amadeus Avogadro. Okay? Amadeus Avogadro. Now, we have to talk about the size of these. So when you go to the grocery store, those of you taking food to know this, are eggs all the same size? No. Generally, if you bake, you use what size eggs? Large. Okay? So, when you go to the grocery store, you can get eggs that are small, medium, and large. They're not the same size eggs. Now, I only use them to make scrambled eggs. I'm terrible at baking. So, you got to know where your strengths and your weaknesses are. Baking is not my strength. My children will tell you that. If we need food that is baked, I go to a bakery. So, when I buy eggs, I buy extra large because I'm only making scrambled eggs in my house. When we talk about moles, are they the same size? Were eggs all the same size in the carton? I all had 12, but were they all the same size? No. Are all my atoms over there and my moles going to be the same size? No. So, how are we going to find the size of my atoms? The what? There we go. I was worried for a second. There you go. So, we got our periodic tables handy. So, what is my atomic mass for carbon? Tell me, I already said it. 12.01 grams. All right. What's my atomic mass for phosphorus?
30.97.
All right. And for arsenic?
74.92.
Now, I can do most of these to the first decimal place. However, I will not give them to you for a while simply because you need to locate where these elements are on the periodic table. And you can't get good at finding them if I'm always giving you the information. Eventually, I will just slap it on the board because I will assume you can find them at some point. And if you can't, too bad, so sad. All right, now, why do they have different masses?
Because they're different elements.
I need something more specific. Why are the masses different? And there you go. They have different protons and neutrons. Okay? The protons and neutrons are different, which is why their masses are different. All right? But inside doesn't make them a different number of atoms. Think about it. You have 12 eggs in the carton. Okay? The eggs are different in size because the yolk and the clear gooey stuff is a different size. Okay? So we have the same number of atoms in a mole, but the only thing that makes them different is the number of protons and neutrons inside. But the number of atoms sitting in the bucket is the same. Okay? That's the only thing that makes them different. Now, what are we going to do with this information? We're going, we are. We're going to learn how to convert. So we have two conversion factors that I probably have written down. Yes. Let's see if I can. Copy. Oh, I can't figure out how to do it with my fingers. Yeah, I don't know how to double click with my fingers. That's the problem. All right. It could be. All right. So you don't have to write that bottom line if you don't want to. The two conversion factors we're going to use are these two right here. So the first one that we learned, hold on, I'll put the screen there where y'all are all. All right, so the first one we learned is 1 mole is equal to 6.022 times 10 to the 23rd atoms. And again, this is called Avogadro's number. Okay? So if you don't like yelling out the number, you can just say Avogadro's number. Means the same thing. Like 1 dozen is equal to 12. 1 mole is equal to this number. Now, the second conversion factor we just wrote down is 1 mole is always equal to the atomic mass, which will be in grams. These are the two things we're going to use to work some sample problems here in the next, I don't know, 15, 16 minutes. Okay? And this is why we learned the factor label method, because this is how we're going to solve. Does everybody have what we need? All right. So, and I have pasted this with the word problems on all the screens. All you need to write down is the word problem here. I just have the other so it's there and I don't have to keep writing it. Right? You just need the word problem. How many moles of phosphorus are there in 23.69 grams? Now, all of these problems will require significant digits and a unit. The quiz on this will be Wednesday, by the way. I will not give you one on Tuesday because we will not be ready for it Tuesday. Half of you will come back Tuesday and be looking at me like, I know how to do this.
Yeah.
Not all of you.
What is your Saturday early wait for you?
So what?
Sorry. Are we supposed to solve this or just wait for you?
You're supposed to wait.
Okay.
All right, has everybody had a chance to write it down? All right, what was the first thing we did when we did the factor label method? When we did King Henry died by drinking chocolate milk, what's the first thing we did? We did what? I heard it. Set up a chart. Okay? So, set up a chart. All right, now that we set up a chart, what's next? What goes on the top?
23.
The 23.69. What you're given always goes on top. So what am I given? So 23.69 grams goes on the top. All right, what do we put on the bottom? What do I want to get rid of? What do I want to get rid of?
The grams.
It goes on the bottom. All right, what do I put on top?
The 6.
Not yet. What I want, right? What do I want? I want some moles are going on top. Okay, y'all are trying to put numbers in. We don't even know what unit we want yet. All right, so we got grams on the bottom to get rid of, moles on top because that's what I want. Now that I know this, now we can look at these two conversion factors. Which one do I need? The top one has moles and atoms. The bottom one has moles and grams. So which one has moles and grams? The second one. So I don't need this one. I need this one. What is in front of moles?
1.
I put a 1 there. What is in front of grams?
Atomic mass.
So I look at the periodic table and I say, oh, I had phosphorus. So I look up the atomic mass of phosphorus and I put it right there beside grams. So what's the atomic mass of phosphorus? So I put 30.97 here. And then I calculate.
Oh, okay. What does this have to do with all the other stuff you just said?
Right.
The eggs and stuff.
I'm telling you how it's related.
This is related to eggs.
Oh, because she's saying like.
The eggs are not related to the mole. I'm telling you the way moles relates works just like the egg conversion factor.
The egg conversion.
Is it okay if some of us, just throw away the egg idea if it doesn't make sense?
Yes.
Because
Don't worry about the eggs then. All right. So what do you get for an answer?
0.76493380.
0.7649 and stop because you always look at your given data, which is right here. There are how many significant digits? So I want 4 in my answer. Grams cancel. So I have what unit here?
Moles.
Moles. Question. We're not talking about moles like the critter.
I know, but still.
All right. Next question. All right. Write it down. We're going to do 3 so that you have samples to refer to. All right. How many atoms of sodium are there in 6.87 moles? All right. We got it? All right, so what do we put on the top line of our chart?
6.87 moles.
Good. What goes on the bottom line?
Moles.
What goes on the top line? All right, so this time when I look at this, which one am I going to want?
6.0.
Okay, so I'm not using this one because I don't have moles and grams, right? I only want the top one. So what's next to moles? What's next to atoms? 6.022 times 10 to the 23rd. Now, do we remember how to punch it in our calculator?
Yes.
Okay. 6.87 times 6.022 second EE 23. I need 3 significant digits. So 4.1, you want me to round up?
Yes.
4 times 10 to the 24th atoms. I did. I asked if you wanted me to round. I know the rules. I just don't often do it. I've been desensitized over the year to rounding. All right, everybody got it? Last question. All right, how many grams of nickel are there in 4.98 times 10 to the 24th atoms? All right, what are we putting on the top line?
We
Okay.
need to make one.
Do we need to what?
Make one of those things.
A chart?
Yeah.
No, you can get the question wrong.
Okay, well, Miss Wall, I didn't mean it like that.
Okay. All right, what goes on the bottom? Atoms. Now, typically at this point, we'd write grams on the top line because that's what it asks for in the question, right? All right, here's a new skill for us. We're going to make our charts longer starting today. All right, this is why I have this right here. All right, every chart must have moles in it. If you learn to skip moles, when we get to the point that moles is not always a 1, you're not going to have a place to put the coefficient. Because for those of you who are smart, which is everybody in this room, you have figured out that moles is always going to be a what right now? It's going to be a 1. It's going to stay that way for about 2 weeks till we learn to balance and y'all become sophisticated. Well, in a couple weeks after we've learned to become sophisticated, it's not going to stay a 1 anymore. And if you skip moles in here, where are you going to put your 2s, 3s, 4s, 5s, 6s, and 14s? Great question. So we need to not skip moles. So if we start in atoms, what do we have to go to?
Moles.
Okay. Now, did the question ask for moles?
No, that's for grams.
We draw another little line. And the chart just gets a tad longer. Then we get rid of moles. So where's it got to go?
On the bottom.
On the bottom.
Wait, could we, if the whole long chart is scary to us, could we do the first part and then do the second part?
In a separate chart? Sure.
Okay.
All right. Now, we want what on the top line because what are we going to? Now, this time, we're going to use both of the conversion factors. You just have to put them in the right place. So this one is moles and atoms. So I need which one for this section? The top one or the bottom one? The top one. So moles and atoms is the top one and it goes here. So what did I just tell you always goes next to moles right now?
1.
It'll change in a couple weeks. We're just not there yet. All right. Atoms is going to get what number? What's right here beside atoms?
6.022 times 10 to the 25.
And then grams has what beside it?
Atomic mass.
All right. So we have nickel. Nickel's in the middle of the chart. Okay. Now, how do we punch this in our calculator? You have options. I don't ever use the ones because whatever you do with ones is going to be the same number. I multiply across the top and divide by the bottom because that's just the way I prefer. If you prefer to divide and then multiply, you can. It doesn't matter. Multiplying and dividing are on the same level in order of operations. Okay? I, again, multiply and then divide. But if you want to divide and then multiply, knock yourselves out. 4.98, second EE 24 times 58.69 divided by 6.022, second EE 23. I don't do anything with the ones because anything multiplied or divided by a 1 is itself. So I just leave them out. You can multiply and divide by ones if you want. We need 3 significant digits. So I get 485 grams.
Wait.
Oh, wait, never mind. So you cancel.
Yep. Because I canceled out. Atoms cancel. Moles cancel. And I'm left with grams. Does that make sense?
Yeah, that.
Yeah. 485. It's not scary. It's not a lot. It's okay, Sumatra. You can do this. I have great confidence in y'all and your ability to do this.
Homework.
Yep.
So we need to write the G mold, I don't know if that like,
Where in the world is that?
Say what now?
the third one, do we need to write that thing out or do we write it?
You just write G.
Okay.
Okay? Because the moles cancel out. The atoms cancel out. And I'm going to tell you which ones to do. I don't want you to do the whole thing. You're working all weekend. All right. Find where it says problems. All right. We're doing 1 through 7. B only. 1B, 2B, 3B, 4B, 5B, 6B, 7B. Okay? And under application problem, we're doing 1. Is it? 8 questions. Okay?
So 1 through 7B and application 1.
Yep. Application 1 is an average atomic mass. To go with the convert.
And our quiz is Wednesday.
Your quiz is Wednesday.